Hello and welcome to my channel, where I explain some basic computer science concepts as they are applied to real-world situations. Today I'm talking about the big O and the hidden cost of nested loops, using PHP as my language of choice. There is a good Wikipedia article on the big O notation where the O stands for Ordnung, which means order in German, I believe, as in the order of magnitude. It's a way of grouping algorithms by how they grow in execution time dependent on the input data size. Have a look at the article if you fancy going through the mathematics. But, for our purposes, let's just understand that the big O notation describes how much slower the execution of your code is as your data grows. Let's look at this graph. Note these three lines. O1. No matter how much data you have, the execution takes the same time. For example, looking up value by its key in a PHP array. On. This is linear time. If you have 100 items, your program does 100 steps. For example, a single foreach loop is linear. On square. Quadratic time. This is when things get costly. If you have a list of 100 items and for each item you run another loop of 100 items, you aren't doing 200 steps, you're doing 10,000 steps. In practice, this means that your code may run really fast when you have a small data set. For example, when you're building your application on your machine and you test it locally. However, real-life examples may contain hundreds of thousands of data points, and if you're not careful, the execution may take a long time. This means that your end user may get the dreaded server timeout screen. We really don't want that. Okay, let's see an example. I created this file bigoexample.php. Let's pretend you have a web store with hundreds of thousands of products, but you don't want to display them all. You just want to display maybe 5,000 of them. And the way you get all these products, it may be from the database, it may be from a third-party API call, and they all come unfiltered, so you want to filter the products, so just display the ones you want people to see. So let's start with an array called products. It's just an empty array to begin with, and then we will create 10,000 objects to store in this products array. So for I equals 0 to I less than 10,000, I plus plus, and inside the loop we will simply create the objects. So products, new object is something like this. This object might have an ID, which is simply the I, and it might have a name, which is simply product I. Okay, so we have 10,000 products, and let's say we have 5,000 favorite IDs. Fav IDs equals range, let's say 5,000 to 10,000. This will give us an array of 5,000 IDs that we want to filter our products on. So how do we do that? Well, one of the most common ways that I've seen is to have two nested for each loops, something like this. For each products as product, and inside we will loop through our favorites. For each fav IDs as FID, and simply compare the IDs. If product ID is identical to FID, we will store it in an array called favorites. favorite products. New one is simply product, right? We need to initialize our fav products array. And before we start this operation, let's start our timing function. So start equals micro time true. Then we do these two loops, one inside the other, and we will assume that we have an array of favorite products. So let's see how long that takes. So we'll say end equals micro time true, duration is equal to end minus start. And let's see how many seconds we have. Echo time it took will be number format duration, and let's have new line like that. So let's run this. We say PHP big O example. Let's see how many seconds this takes. It does take only seconds, but we are dealing with very, very simple objects, and 10,000. So let's see, it took 9.6577 seconds. Now, in this case, it wasn't too bad, but imagine we are dealing with real life. This might take a long time. So how do we deal with this? What is the solution here? Can we speed it up? And the answer is yes. Basically, to speed this up, I would take the fav IDs array and call it lookup array flip, and we're flipping fav IDs. So what this will do, it will take the values, the IDs that we have in this fav IDs, and flip them into array keys. And then we can use this array of keys to look up our product. So in this case, let's just comment out this block right here, and instead we will do something like this. For each products as product, we say if is set lookup and product ID. If this ID of the given product exists in our lookup array, then we say fav products is equal to product. Simple as that. So we don't have nested loops. Let's see if this improves our execution time. Let's do this again. It took 0.0343 seconds. Let's play with this a bit, and instead of 10,000, let's say we have 100,000 objects to flip through, to search through. So that's 100,000, and let's see how long our first method will take. And I will comment out the second. Yeah, and save this, and let's see how long that takes. It will probably take about 90 seconds. Right, I cut out the waiting time so you don't have to watch that. Basically, it took 96.6 seconds to go through 100,000. object. Now you don't want your end user to wait 96.6 seconds. So let's see if our second method will improve this in any way. So I will comment out my first method and enable the second. It took 0.3303 seconds. So, okay, a significant improvement. By using array flip, we turned our search list into a hash map. In PHP, checking is set on a key is an O1 operation. It's a direct lookup. Now instead of 50 million operations, we do 5,000 to flip the array and 10,000 to check the products. We just went from 50 million steps to only 15,000 steps. That's the power of understanding the big O. Nested loops are definitely an issue. Also, look out for PHP's array functions such as inArray, array search, array merge, array unique, and array diff. They all take a lot of time to complete and may take a lot of memory. They look like a single line of code, don't they? But they hide inside a foreach loop. This is the number one way PHP developers accidentally create O(n) square complexity. So what's the conclusion? Avoid loops inside loops. Avoid quadratic time algorithms as they are very costly. Use PHP arrays as they are highly optimized hash maps under the hood. Think about scale. What may work in your local environment might not work in production when you deal with real live data. Plus, if you speed up the execution of your code by orders of magnitude, your boss will be very happy. But of course, it's not just about a happy boss. It's about lower server bills and a faster experience for your users. Thank you very much for watching. If you like this video, please share and subscribe. Or you can buy me a coffee. Thanks again and stay tuned for the next video, which is coming soon.